Hey guys, in today's video we'll be covering Unit 2.6 of the Math AA, SL and HL course, which is quadratic functions. Since this video is quite long, I've put some timestamps on screen right now that you can skip to, so you can focus on whichever area you need to focus on. So first we'll begin with the standard form of your quadratic functions. And this is f of x equals ax squared plus bx plus c, where your a, your b, and your c are just any real numbers. Okay. And this A, this B, and this C, so your A, B, and your C, we call these the parameters of your function. It's a nice little keyword for you to remember. These are your parameters. And these parameters can be any real number, again, except for one rule, which is A cannot be zero. So this can be zero, this can be zero, this cannot be zero. There has to be an x squared value for this to be considered a quadratic. Okay. And now let us sketch this quadratic. Let's draw the graph. Uh, And your quadratic will always look like this when you sketch it. It will always be in the shape called your parabola. And this should actually be symmetrical on both sides. My bad. But your parabola will always be like this. It will always be opening upwards, or it can be opening downwards. It can look something like this. These are both called parabolas. And how do you know when your thing will look like this or like this? It's very simple actually. Uh, it will be opening upwards. It'll look like this when your a value, so this a here, is positive. So if you have 2x squared, you immediately know it's going to be something opening upwards. And on the other hand, if it's negative, if this here is negative, then your graph will open downwards. It'll look something like this. So this here is when a is bigger than 0, when a is positive. This is when a is smaller than 0, when a is negative. Okay. And so here we have your two parabolas. You have one that goes like this and one goes like this. These here, these two, as we discussed earlier, are the turning points. It's where the gradient changes. And this is a minimum point, this is a maximum point. But we can just generalize these two and we can just call them the vertex. So in quadratic functions, the turning point, which can be their maximum or minimum, depending on if a is positive or negative, is always called the vertex. And what are the coordinates of the vertex? These can easily be found using, so the vertex, coordinates of the vertex are minus b over 2a and the function of minus b over 2a. And you may be thinking, oh, where did this come from? I will explain it real quick right now, but it does kind of need calculus. So if you don't understand, it's fine for now. Just remember minus b over 2a. But basically, we just know that since these are turning points, first step in finding a turning point is to find the derivative of the function, which would be 2ax plus b, right? So the derivative of this function is 2x plus b. And then the location of the turning points is when the derivative equals 0. 2ax plus b equals 0. Then you just solve for the x. 2ax equals minus b, x equals minus b over 2a. If you didn't understand this, again, just don't worry about it. Just remember minus b over 2a. That's all you need to know. You don't need to know how you got it. And then if this is your x coordinate, just plug this in. Function of that is your y coordinate, like any other function. So this is your vertex point. And one more thing. So if your parabola looks like this, right? If you draw a line right through the exact middle, then this side should look the exact same as this side. It should be symmetrical, right? So this line here, this imaginary line we drew, is your axis of symmetry. And as we just said, the axis of symmetry is in the exact middle of the parabola. And what else is in the exact middle? The vertex. So very simple, your axis of symmetry is when x equals minus b over 2a, just the x coordinate of the vertex. It doesn't have a y coordinate because it runs through the whole graph, but the x coordinate is just the x coordinate of the vertex. And one more important feature of your standard form is the y-intercept. So the y-intercept. And we know that the y-intercept is when x equals 0, right? So the function of 0 would equals a 0 squared plus b 0 plus c. And these are multiplied by 0, so they just cancelled out, and you have your c. So your y-intercept is always just your c here. This is your y-intercept. So when you have a standard form function here, first of all, you look at this to know if it's positive or negative gradient, or sorry, concave up, concave down. So if it's facing upwards, facing downwards. And then you look at your c value here, and that is your y-intercept. This is where your graph will touch the y value. You can either touch it like this, etc., etc. But yeah, this is your standard form of a quadratic function.
Okay, next we have vertex form. And vertex form is essentially just another way of writing down a quadratic function. We had standard form, which is ax squared plus bx plus c, and now we have vertex form. And vertex form is essentially f of x equals a x minus h squared plus k. And what does any of this mean? Well, as we discussed earlier in the video, the vertex of a function, of a quadratic function, is at the points minus b over 2a and the function of minus b over 2a, right? Now, oh, okay, now let's say that this minus b over 2a here is h, and this f minus b over 2a is k, okay? H, h, k, k. This is literally what it means. So this h here is the x-coordinate of the vertex, and this k here is the y-coordinate of the vertex. Okay, so let's say we had a function, for example, f of x equals 2x minus 3 squared plus 1. We have this 3 here and this 1 here. We can immediately realize that this is the x-coordinate of the vertex and this is the y-coordinate of the vertex. So if we go to draw a graph, right here, let's say, we immediately know that the vertex is at x equals 3, y equals 1. X equals 3, y equals 1. And we also know that this 2 here, or this a, works similar to the a in standard form, where if this was positive a, then the graph is concave up, and if this is negative a, then the graph concave down. So since this is a positive 2, this is positive 2, we know that our graph will be going up like this, right? So since it goes up, that means there'll be no x-intercepts. So the other key feature of this graph would be the y-intercept. And how do we find this y-intercept? Well, if you remember from standard form, we said that ax squared plus bx plus c. The c here, the c, is the y-intercept, right? So this is y-intercept. So why don't we put this function in this form and then find out what the c is, right? So how do we do this? First, we just expand what's in this bracket. We expand this x minus 3 squared. So we have f of x equals 2, and we expand it, so it becomes x squared minus 6x plus 9, and then the plus 1 out here. And then you bring in the 2 into the brackets, so you have 2x squared minus 12x plus 18. Plus 18 plus 1, so we'll just have plus 19 straight away. And this here you have your a, so this is your a, this is your b, and this is your c. And since we said that c is the y-intercept, we immediately know that, oh, this graph is gonna intercept at y equals 19. Obviously this is not to scale, but just imagine it is. And now that we have these two key features, we can just sketch the graph.
So we already discussed that the standard form of a function is ax squared plus bx plus c, and that the vertex form is a x minus h squared plus k, right? And we said that to get from here to here, all you have to do is just expand what's in this bracket. We just have to do x squared minus 2xh plus h squared, etc. And you'll just end up with a standard form. But how do we get from a standard form, quadratic, to a vertex form? Let's have a demonstration. So we'll use the function that we used last time, 2x squared minus 12x plus 19. Now, last time we had this expressed in vertex form and we changed it to standard form. So now let's take the standard form and put it back into vertex form. And how can we do this? Well, first, we know that this h here, so h is minus b over 2a, right? So this h is b is minus 12 over a is 4, so it'll be a is 2, sorry, so 2a will be 4. And then the minuses cancel out and you just have h equals 3. So if we have this function here, f of x equals, the a stays the same, so this a here is the same as this a here, so a would be 2. X, we just got h is 3, and now we need to find k. And as we said, k equals the function of h. And since h is 3, k is just the function of 3. So k equals 2, 3 squared, minus 12 times 3, plus 19. K equals 18 minus 36 plus 19. K equals 1. So plus 1. And now here, like the numbers are pretty simple. It was a pretty simple method to find k. But sometimes you'll start having fractions, they'll start getting complicated, it may start to look a bit ugly. So there's an easier, well, debatably easier method of going from vertex form to standard form. Standard form to vertex form. And this is called completing the square. And what you do is, if we put our function again, f of x equals 2x squared minus 12x plus 19. Now, the first step in completing the square is to isolate this x squared value here. So I'm going to get rid of the 2 and just make it into 1. And you do this by just bringing the 2 out of the brackets. You have your x squared. And since you brought the 2 out, you need to bring the 2 out from the 12 too. So if you bring out 2, it becomes 6, right? Because 12 divided by 2 is 6. And we'll keep the 19 out of the brackets because we're working with the x's for now. So if you bring this back in, it would be 2x squared. Bring this back in, it would be minus 12x. Nothing changed. We just factored out the 2. Now, this next step can be a bit confusing, but what you want to do is inside the brackets, you want to add half of this number squared, okay? So here's 6, so half of 6 would be 3, and we want to square that. And now we can't just add the number, right? Or just completely change the equation. So we can keep the equation same, we can keep it balanced by just subtracting this number again straight away. And we have this plus 19 out here. So again, we added, we subtracted, basically nothing changed. What we can do now is, so we have this minus 6x plus 9. We could close the bracket and then minus 2, 9 plus 19. Because it's basically the same, right? Here it's the 2 is multiplied by every number in here. Now the 2 is multiplied by every number in here, and the 2 is still multiplied by this number. So you'll still get the same values. Just brought this number out of the main bracket and still multiplying it by 2, so you're not changing anything. And now, this number here, this is where you complete the square. Now this here is basically equal to x minus 3 squared. And how do we know this? Well, if we expand x minus 3 squared now, you'll have x squared minus 6x plus 9, right? So, yeah. So you're not changing anything, you're just expressing it in a different way. And this number here, if this is negative, you know this will be negative. And this number here is basically just the square root of the constant here. Okay. And now you're still minusing the 18, minusing the 2 times 9, plus 19. And there you have it. 2x minus 3 squared plus 1. Just completed the square. And completing the square has other applications too. So here we used it to get from standard form to vertex form. We can also use completing the square to find the x-intercepts of a quadratic. And we actually use completing the square to derive the quadratic formula. The quadratic formula was found using completing the square. And I will, as an extension, it's not something you need to know, but at the end of this video, I'll show you how you can find the quadratic formula using completing the square. And next we have our factorized form, which is yet another way of expressing a quadratic function. And this is in the form of f of x equals a x minus p x minus q. Okay, and what are these letters here? Well, first of all, the main use or the main purpose of this form is to find the x-intercepts, or where y equals 0, what are the x values? So again, when y equals 0, f of x is 0. So a x minus p x minus q equals 0, right? What are the x values here? Well, you'd know that either a equals 0, x minus p equals 0, or x minus q equals 0. Because if either of these are 0, since they're all multiplied together, I'll just cancel everything out. However, we know that a is not 0, because in a quadratic function, a cannot be 0. So we'll just ignore the a for now. So here, x is either p or x equals q. Alright, so when y equals 0, x either equals p or x equals q. So when you express your function here like this, a x minus p x minus q, your p and your q here are your x-intercepts. Okay, so let's express this in a graph. So if we draw this graph of f of x here, like this point here would be p, and this here would be q. And now let's find the values of p and q. So to do this, let's first give ourselves a practice quadratic question. So let's say f of x equals x squared plus 10x plus 16. Now the first step is to factor out the a, right? This a here. And since a equals 0, we can just ignore it, whatever. Next step is to write it in the form x plus or minus something, x plus or minus something equals 0, right? Because we know that y equals 0. So what are these plus or minuses here? Basically, you want to find two numbers, so a number here and a number here, which can multiply together to give 16 and add together to give 10. Okay, so two numbers that multiply to give your value of c and add up to give b. So if, let's say, this is like plus p plus q, p times q has to be c, and p plus q has to be b. Okay, let's move this here for now. So let's start by finding all the numbers which can multiply together to give 16. So you can have either 16 times 1, 4 times 4, 8 times 2, right? And now we take all these different situations and we add up the numbers together and we see which one gives 10. So 16 plus 1 is 17, so that's not the one we're looking for. 4 plus 4 is 8, that's not what we're looking for. 8 plus 2 is 10, that's what we're looking for. So our p and q numbers are 8 and 2. So here we have x plus 8, x plus 2. And we'll see that if we expand x times x is x squared, x times 8 is 2x, 8x, 16. It will end up being x squared plus 10x plus 16, which is what we're looking for. So as we said, now we have it in the form x plus 8, x plus 2, right? But we want it in the form x minus p, x minus q. So how can we put it like this? Well, you can just rewrite it as x minus 8 times x minus 2, right? Because we want this to be minus, not plus, and minus times minus is plus. So now we have it in the factorized form. We just now know that p equals minus 8, q equals minus 2, right? Because it's x minus p, this is p, x minus q. So your x-intercepts here would be, well, I'd have to move the graph across. Oh, it would be here. This q equals minus 8, p equals minus 2, right? These are your intercepts. And this is one easy way to do it, right? But let's say you had another function, something that looks like, let's say you had 2x squared plus 5x plus 3. And now it gets hard to do what we did before, like finding two numbers that multiply to give 3. Oh, you'll get fractions, disgusting, weird numbers. I don't know. So what do we do now? This is where your very trusty, very iconic quadratic formula comes in. X equals minus b plus or minus root b squared minus 4ac over 2a. And I'm pretty sure everyone has used this formula at least once in their lives. It's everywhere. Um, at the end of this video, I will be showing how you get this formula. But for now, you don't even need to memorize it because it's in your formula booklet. Just know how to use it. X equals, b is 5, so minus 5 plus or minus root 25 minus 4 times 2 is 8 times 3 is 24 over 2 times a, so 4. X equals minus 5 plus or minus root 1, which is just 1, over 4. So you'll have x equals minus 4 over 4, or x equals minus 6 over 4, x equals minus 1, x equals minus 3 over 2, right? And okay, first let's just put this in factorized form real quick. So now we have x minus minus 1 would be x plus 1. X minus minus 3 over 2 is x plus 3 over 2. And there you have it. That's your quadratic expressed in factorized form. And another key feature which we can find from this is your axis of symmetry. Okay, and what do I mean here? Well, I'll just remove this real quick. Now, you know that your graph intercepts the y-axis, or the x-axis, sorry, at minus 1 and minus 3 over 2, right? Now, if your graph is perfectly symmetrical, right, your axis of symmetry, your axis of symmetry should be in the exact middle from these 2 points, right? Because it's symmetrical. So the vertex, or your axis of symmetry, should be in the exact middle. And how do we find the exact middle? Very simple, actually. We'll just do, so axis of symmetry equals p plus q over 2. This is the middle, the midpoint, right? So if p here is, for example, in this case, p is minus 1 plus minus 3 over 2 over 2, which would be minus 5 over 2 over 2, which is equal to minus 5 over 4. So this x equals minus 5 over 4 for your axis of symmetry here. And as we know, the axis of symmetry lies on the vertex. So, or the vertex lies on the axis of symmetry. So this is not only the axis of symmetry, but it's also the x-coordinate for your vertex. So a lot of information that you can get out of the factorized form. And now a nice little past paper question to finish the video off. This is a four-part question which covers kind of the entire subunit, so it's a pretty nice question. First question gives you this function, asks you to find the x-intercepts. And again, to find the x-intercepts, we put it in factorized form, right? Or we could use the formula, but that just, that takes a bit too long. So factorized form, again, x plus or x plus minus something, x plus minus something. And first, let's look at all the numbers which multiply together to give minus 5. So we can either have minus 5 times 1 or minus 1 times 5, right? And minus 1 plus 5 is minus 4. Minus 1 plus 5 is 4. And what we're looking for is minus 4. So the two factors, p and q, are minus 5 and 1. So here we have x minus 5, x plus 1, right? And so since x equals x minus 5, x plus 1, therefore x equals 5 and x equals minus 1. So those are the two x-intercepts of the graph. So this here would be x equals 5, and this here would be x equals minus 1. And the next question asks for the axis of symmetry. And as we said, the axis of symmetry is the exact middle of these 2 points, right? So how do we find the exact middle? We just add them up and divide by 2. So for axis of symmetry, it will be 5 plus minus 1 over 2. Axis of symmetry. And axis of symmetry, so 5 plus minus 1 is 4 over 2 would just be 2. So the axis of symmetry, that's here, is equals 5 minus 1. This equals 2. And now the next question, it's telling us to put it in essentially in vertex form and to write down the value of h. And if we know that h is the vertex here, right? This is h. And the axis of symmetry runs to the exact middle. The axis of symmetry, as we said earlier in the video, is the x-coordinate of the vertex. So h, in this case, would also be 2. H is the x-coordinate of the vertex, the axis of symmetry is the x-coordinate of the vertex, therefore h equals the axis of symmetry, right? And finally, find the value of k, where you said that k equals the function of h. So since h is 2, we just need to find the function of 2. So if f of x equals x squared minus 4x minus 5, the function of 2 would be 4 minus 8 minus 5, which would be minus 9. So k in this case is minus 9. And now just a nice little extension, not something you need to know, but something that I find pretty interesting. And this is where the quadratic formula came from. Like it didn't just come out of thin air, it came from somewhere. And this is the derivation of the quadratic formula. So first you put your quadratic in standard form. So ax squared plus bx plus c, right? And we'll let it equal to 0. Because when you use the quadratic formula, you're using it to find the x-intercepts. So you're using it to find 1y equals 0, right? And now what we want to do is we actually complete the square. So as we said before, first step in computing the square is to isolate this x squared here. So we bring out the a, x squared plus b over ax, oh, x, and we'll keep the constant outside the brackets, right? And what we want to do next is, when you complete the square, as we said before, you add half of this number squared and then you subtract it. So you add half of this squared and then you just subtract it straight away so that nothing will be changed, right? And then we'll just bring this c here to the other side. So we'll just minus c. Okay. And then again, so you rewrite this to a squared, and you move this here out of this bracket. Just put it in another bracket, but you still multiply it by a to a squared. And you know what? Let's actually square this here now. So the b squared would be b squared, and 2a squared will become 4a squared minus c. And you'll have this a here multiplies and cancels out this a, right? And now, oh, let's put it here. Now you just want to complete the square here, and you do this by x, well, x plus b over 2a squared, okay, equal minus b squared over 4a equals minus c. And you know what? Let's actually bring over the b squared over 4a, so b minus c plus b squared over 4a. And the next step here is to just divide both sides by a. So you have x plus b over 2a squared equals minus c over a, or let's put this first, so b squared over 4a squared minus c over a. And we want to have these denominators the same, right? We want to have a common denominator so that we can combine these two. And to do that, you just multiply this by 4a. What you do to the bottom, you must do to the top. So this would be b squared minus 4ac over 4a squared. And if you know the quadratic formula, you already see this is starting to get kind of familiar, right? And what we want to do next is we want to square root both sides. So we want to square root this, square root that, to get rid of the squared on that side. So now we got rid of the squared, we just have x plus b over 2a equals plus or minus, because the square root is always plus or minus, the square root of b squared minus 4ac over the square root of 4a squared. And we can actually rewrite this, so plus or minus square root of b squared minus 4ac. And we know that the square root of 4a squared is just 2a, right? Because 2a squared is 4a squared. And finally, we just bring this b plus 2a over to the other side. Just subtract it, minus. And what you have is x equals plus or minus root b squared minus 4ac over 2a minus b over 2a. And yep, this is it. This is your quadratic function. X equals minus b over 2a plus or minus root b squared minus 4ac. This is a derivation of the quadratic formula. Again, it's not something you have to know, but it is pretty interesting and it gets you thinking on a higher level.